Well, hello everyone. Welcome back to the Tin Barn. I'm Pragmatic Lee, and today's project is going to be a little bit of a follow-up to one from a few weeks back. A lot of interest and seem to be in these steam whistles, or air whistles in my case, that I put together. I've got one outside my shop that I use occasionally to just let the neighbors know I'm still around. As I said when I built these in that video, they really got no practical use. Well, at least I didn't think they did, but I think I found a practical use for one, and that is to entertain children. A friend of mine is a member of an antique tractor club, excuse me, and they've built a little train that they pull in Christmas parades, Veterans Day parades, Labor Day parades, any kind of civic parade that they take part in. The cars are made out of 55-gallon drums, I believe, and they pull it with an old garden tractor. And the tractor belongs to a friend of mine named Rex. And I asked Rex a while back if they had a whistle for their train, and he said they didn't. Yesterday at church during Sunday school, or before Sunday school, he asked me about if I was still making them, and I kind of took that as a hint, as maybe Lee, I want one to go on the train. So I put him one together. I didn't bother to video this one. You can video the build. It was from just a couple weeks ago, where I built several of these. In fact, I believe this is the 5th or 6th one that I've built. The 5th one. This is the 5th one. But what I'm going to do, I've used in my setups and just sitting around here, I've just used the air fitting under the bottom to mount it on top of a manifold, or just a simple mount with air fitting. But he's going to use this, mount it on his little train, and they're going to carry a gasoline operated air compressor with them. So I'm imagine he'll have some kind of a little car built for that air compressor as well. So he'll likely need some kind of a mount to mount this. So that's what today's project's going to be. We're going to take some aluminum stock. I'm going to make a little bracket similar to this. That hole in there will be the size of the bell, or the cup as it's called. We'll split it on this end, put a 1/4-20 socket head cap screw countersunk in there so it can squeeze down on it. On the back of it, I can show you this holding the pieces up. This is a piece of, let's see, 2.5 inch by 3 inch by, I believe that's 3/4, yeah, 3/4 inch thick stock. And also on the back of that, the hole will be, of course, in here. And on the back of that will be a piece such as that, with holes in each end, that he can mount to whatever bracket he has on the tractor or the trailer, or whatever's close by where he can reach it to open the valve and sound the whistle out, and hopefully give a little entertainment to some children in parades. So I'm going to lay out some marks on here, and then I'll meet you over on the mill and we'll start machining this piece out. I've got the main body of what's going to be our mount over here in the mill vise now. And as I showed on the drawing, this center hole right here is, or this hole is off center. It's 1 3/4 inches over. That gives us plenty of room for this split on this side and the tightening bolt over there, and leaves just a little bit over here for the hinge portion. So I've got it set up now, got it zeroed over there, and go ahead and zero out my DRO so I don't forget that. Got a starter drill in there, centering drill. This hole will need to be just a little under 2 inches. From the earlier video where I actually made the whistles themselves, for the bell or the cup, I started with 2-inch stock and then turned that just enough to make it round and clean it up, which final dimension was about 1.9. A 1-inch drill is the biggest drill bit that I have. So we're going to drill that, and then we'll put the boring head in. Got the boring head in now and got it touched off, and we're going to take about 50 thousandths per cut. That'll be 100 thousandths on the diameter, 50 thousandths per side. Okay, I'm going to continue that process until we get a little bit closer to the actual dimension, then I'll bring you back. All right, the dimension we're looking for is about 1.985, something like that. Right now we have .8. So let's take another 100 thousandths. We'll see how close that brought us. And what we're looking for is, again, a good slip fit. Doesn't have to be tight by any means. All right, I've got the DRO zeroed out, so I'm going to move the table out here where we can actually measure the piece. Okay, that's a good slip fit right there. I want to get all the holes drilled in the piece before I actually cut the slit in there. So I'll get that set up and we'll come back. All right, the main body of the mount, got the hole cut out in it now and got it deburred, got it cleaned up around on both sides. And I marked with red Sharpie there the end that I want to drill the holes in, because I just wanted to be sure I put them in the right side. Remember, this side we're going to put a slit in and a screw in this direction, tighten down. For these holes back here to mount the 1-inch bracket on, I'm going to use an 832 socket head cap screw. The reason I'm using that is because I got several hundred of them, and the head on them is such that I can still counterbore it in this piece and still have some stock material left. So what we need to do first is find the center of this piece. Zero out the DRO. And as you've seen me do hundreds of times before, simply going to double check that. And that zero within a tenth of a thousandth, a 10,000th. All right, that repeated. So we'll take half of that value. And that's our y-axis center. All right, we have center in both directions now. I'm going to put my tap drill for an 832 in. But first probably need to, since that's such a small diameter drill, We'll start with a counter with a centering drill. And for these holes, I'm going to go 1 inch on each side of 0. All right, now I'm going to get my tap wrench, tap guide, and get set up to tap these holes, like say 832. All right, I've got the 832 tap in the tap wrench. Got my tap guide up here in the collar. And I'm going to move over to this one. Preload the tap guide. I like to power tap whenever I can with this mill, but this number 8 tap right here, I don't like to take the chance even in aluminum power tapping. I'd rather be able to feel the pressure on the tap. And I like to use the tap guide as well to retract the tap. That makes certain that you're keeping the tap straight. You're not leaning it over enough to bend it and break it off in the material. All right. Now we'll get set up to drill and counterbore the matching holes excuse me, in this piece. As you recall, I put these holes in the center of the y-axis on this piece. This is 3/4. This is a 1 inch piece that we're going to be using on the back. So I don't want the holes in the center of it. I want this piece to be offset, flush with what will be the top edge of it. So I'm leaving the y-axis, I'm leaving the mill table locked down right where it's at. Put some parallels in. And for this piece, we don't have to be in the exact center as long as our holes are 1 inch off in each direction of where we're starting. So that is a 4 inch piece. So I'm just going to mark 2 inches. Just put a little scribe line there. And I will line up the starter drill with that mark. And then we'll go 1 inch in each direction. All right, I'll set my 0 there. Now, as I say, we'll move 1 inch in each direction. For number 8 screw, I'm going to use a 11/64 for the through hole. Need to countersink down about 0.15, about 1.160. So we'll put the countersink in. And 0 out the z-axis. Now let me grab a 1/4 inch drill bit and we'll come back up and set up to drill the actual holes that will be used to mount all this on whatever Rex comes up with on the train car or the tractor, wherever he mounts this. Okay, the two holes are going to mount on the, or drill in the end of this. We want them in about the center on the y-axis on here. So remember I had 3/8 of an inch off the edge. So the difference between 3/8 and a half is 125. So we'll advance that over, and that'll be plenty close for the circle, for the center on the y-axis. Now for the position on the x-axis, this piece is 4 inches, our other piece is 2.5. So we had the center marked. If we come 1.625 from the center in each direction, we'll be 3/8 of an inch from the edge. And this is just going to be a 1/4 inch hole with no countersink or counterbore at all in this. All right, I'll get this piece deburred and set aside. Then I'll put our main housing in there to put the slit in the side of it. I'll get the slitting saw in. Okay, I still haven't moved the mill table as far as on the y-axis. So I brought it back to the 0 we had when we drilled the holes in the back edge of this. So that put it in the center. I have the centering drill now lined up on the center on the X, I'm sorry, on the Y, and 3/8 of an inch in from what will be the front edge. Now we'll be using a 1/4 20 socket head cap screw, and I'm going to get and just with my pencil here, just mark an approximate depth of how deep that needs to be drilled. I'll tighten my tighten my chuck down good enough so I'm sure it won't slide through there, or the bit won't slide up in the drill. But what I'm going to do is move off the y-axis for just a second. Come down here to that pencil mark I just made. I'm going to zero out the DRO Z-axis. I'm also going to set the depth gauge. I'll kick the camera up just a little bit and show you what I'm setting up here. Like many drill vices, or like many drill presses, there's a stop on there. I added this stop onto here some time back. I'll tighten that down good. That will just keep me from drilling out the bottom. So we'll bring this back to the 0 on the Y. And I had to move it over a little bit to get off the vise, so we'll bring that one back to 0 as well. And we're going to drill down to our stop. This is the tap size for a 1/4 20. Now, of course, as deep as I'm drilling here, I'm going to have to clear these chips quite often. Alright, let me get you back down where you can see what I'm actually drilling here. All right, and that's to our stop. I'll just clean out some chips there. All right, that is the tap drill, as I say, for the 1/4 20. Now we need to drill down 1/2 of this, the width here, for the clearance drill for 1/4 inch. All right, and I'm going to set the DRO, Z-axis DRO to 0. We said this is a 2.5 inch piece. So we want to go down 1.5 inch and a half. And when I'm getting close like that, I'm sure drilling aluminum, the drill hasn't slipped in the chuck, but I like to recheck that 0, which that's good. A lot of times put a lot of pressure on drilling steel, that drill may slide up just a little bit in the chuck. All right, there's 1.5 inches on the clearance side. Now we want to counterbore that for the socket head cap screw. Bring that down, 0 out the Z-axis again. And as we've talked about before, on a socket head cap screw, at least in imperial sizes, if you're dealing with a 1/4 inch wide, the depth of the head is the same, the head thickness is the same dimension as the width. So we need to go down 250 thousandths. And that clears. Now what we need to do is tap to the bottom of the hole. I'm going to use a starter tap to get it started, and then I'll come right back out and put the bottom of the tap in. Again, we're going to use the tap guide here to keep it straight. There won't be a lot of threads in there. That's why I want to come right back with the bottom tap now. I say not a lot. There'll be about 3/8 to 1/2 inch of threads in there. And it should be started straight now. All right, that should be the bottom. Now we can take the drill chuck out and put the slitting saw in. I've got the slitting saw mounted in the mill now. And I'm going to move this over and just touch off on the top of it. And then 0 out the Z-axis DRO. The slitting saw is an 1/8 inch slitting saw, so half of 0.125 is 0.063. This piece is 2.5 inches, so half of that is 1.250. 1.250 plus half the width of this, 063, is 1.313 that we want to bring our DRO down to. All right, and now we want to easily slid into that. We're going to start up here in this direction. Be sure everything's going to clear. I'm going to start there. I'm not sure if my spindle's going to clear right there. If it don't, I may have to come in here from this side and this side as well. I'm going to go in a little deeper. I'm right on, not quite touching my spindle. And that's not quite going to clear, cut all the way through. So what I'll do is come over here now. Now we need to go to the back side to clear that last little bit. And that's going to be climbing, but there's only a minute amount left in there. All right, the slit is all the way through now. I'll get this sharp saw out of the way and then we'll test and be sure I've got it, got the clearance hole deep enough in there before we take everything out of the vise. All right, that's starting in there just fine. And maybe you can see, let me get the camera zoomed in just a little bit down there. This gap right here is what we're wanting to close up when we tighten that screw down, and it is working fine. So I'm going to go back over to the bench, carry over there. We'll put this together and do a quick recap. One more thing before I carry this over to the bench and put it together and do the recap. I'm going to carry this over to the belt grinder and just put a little radius on these corners. All right, I believe we got all the pieces together now, or pieces made for the mount for the air whistle. So we'll put them together right quick. So there's the mount itself. Now we'll put the air whistle in. And get that spaced about evenly high and low. Just a little squeeze in there. So let's see if I can back out just a little bit so you can see what we've got here. All right, so here's the entire whistle and the mount. I'll just screw a little air fitting in there now. And be sure the mount don't impede the whistle. If you haven't seen the video where I make the whistles, I encourage you to go back and look at that. It was a fun build. I enjoyed it. I enjoyed making this mount. I hope Rex and his friends can use it on their parade tractor, parade train. And most of all, I hope it maybe brings a smile to a kid or two during the parade. Take care, and I'll see you on the next video.